Hi everyone, welcome to the Crunchy Codes. My name is Sonu Kumar. Today I'm going to discuss one more project, and the project title is Cement Strength Prediction. And this is the supervised machine learning problem we are going to solve today. And first of all, I will give the overview of this data set. Also, the pre-condition or prerequisite of this project is the person who knows machine learning and Python programming. They can understand this code fairly well, and who are the beginners, they can also watch to get the intuition how we are using machine learning to solve the industry related problems. And they can by modifying some changes in this code, they can use in their resume or their in project in their college. Also, I want to tell this is my GitHub profile. After clicking on this link, you can and writing this cement distance prediction, you can get this and you can clone this project. So yes, let's get started. First, the data set. We are taking from the Kaggle, and it's a open source data set, so we do not need to worry about to collect the data. It's open source. And what are the features in our data set? First, I'll click on that link, from where you can get the data, and these are my features. Features is cement, blast furnace, slag, fly ash, water, super plasticizer, coarse aggregate, fine aggregate, age, and the target column is strength of the cement. So what is the main agenda? The main agenda is not to only solve and got better result, understand the process and learn from the journey. Okay, and this is in CSV format. We will see the data, and this is the more information about the data set. The first feature is cement, and what is the unit of this cement? It is in 1 cubic meter of the concrete mixture, measured in kilograms. And what is cement? Cement is a binding material responsible for providing strength and durability to concrete. Second feature is blast furnace slag, and it is in kg in a cubic mixture. So what is blast furnace slag? It's a byproduct of the iron and steel industry, and it is commonly used as a supplementary cementitious material in concrete production. What is fly ash? Fly ash is a waste product from a coal combustion, and it is often used as a partial replacement for the cement in concrete to enhance its property. And water, we all know, and it is for the hydration process of the cement, and it is for hardening of a concrete. What is super plasticizer? Super plasticizer is they are the chemicals admixtures, and they are added to concrete to enhance its workability and flow without compromising its strength. And what is coarse aggregate? The coarse aggregate, the large particles such as crushed stone, gravel, and recycled concrete. Okay, which provide the strength and stability to the concrete. What is fine? Fine typically consists of sands and is responsible for the filling the gaps between the coarse aggregate, and it's contribute to the overall strength and workability of the concrete. What is age? Age is measured in day. The age that concrete is measured in days, which the compressive strength is determined. Concrete gains strength over the time as the hydration process progresses. So yes, and what is uh, concrete compressive strength? It is measured in megapascal. So it is the strength of the concrete specimen. Now, what is the problem statement? The problem statement is to accurately predict the strength of new concrete mixture based on their given input characteristics. And this is the date when I did this project. Here is the link. After clicking on this link, I can get the data. And what the techniques and algorithm I'm going to use is linear regression, random forest, XGBoost. Okay, and conclusion we will come to later on. Now, going to the iPython notebook. Again, same thing here, pasted. So first step is to import the libraries. Here, NumPy is I'm importing NumPy, pandas, maths, min max scalar trend test displaced, basically numpy for the numeric operations, pandas for the manipulating the data, and this is the scikit-learn, majorly like it's a popular library used for machine learning tasks, and cboard and matplotlib for plotting, and warnings to import the warnings when I'm running the code. I don't want to get the warning, so that is why. Now this is my dataset concrete data dot underscore csv, like first to get the data using this function pt.read underscore csv. I'm giving the path of my dataset, and I am loading this data into this variable dataset. Now I want to print the first few rows of my dataset, so on top of it I'm running the function dot head, and this is my data. See, and also one more thing is that these are already converted into numeric term, so we don't need to bother. And this is my dependent feature, and this is my independent feature, also called target variable. So you want to predict the strengths. Again, the next function is dataset.info, which means it will give like the information about the dataset. If I want to see how many null values are there in my dataset, also the data type. So this is my data type, and this is my columns, and we can see like there is no null value present in my dataset. And next function dataset.describe. Now I want to get the stats of my data, like what is the count, mean, standard deviation, a minimum value 25 percentile, 50th percentile, 75, and max value for all of my features. So, and what is the agenda behind this? Why we want to get this stats? Because I want to see my mean value and my 50th percentile. If the values are not closer, which means they are that feature is not following normal distribution, and we want to like we want our feature to be normally distributed, because many machine learning models are built on the assumption that the data set is in normally distributed. So that is why. Now we can see for all of the features. Now the next step is to check the duplicates, and I'm using this function dataset dot duplicated. So it will give the and it will give the data set which have like the observations are repeating, and I'm taking the length, which means it will give the count. So 25 observation is duplicated, so I want to drop them, so I'm using dot drop underscore duplicated, and I'm passing one parameter in place equal to true, which means I want to change my like this operation in my original data set itself. That is why. Now again I'm printing the length of my duplicated rows, so I'm getting here 0 because I already deleted. So now again, and then the next function is dataset dot columns, and after this the list of the columns I've got the total columns in my dataset. Now the next step, exploratory data analysis. Although whatever we are we were doing this also called the area process. Now I'm using the list plot, which is the distribution plot from C1 library, and from the dataset I'm giving the target variable, which is my strength. I want to print. So how it is distributed. So this is the distribution. We can see like it is normally distributed almost. Now the next step, I am taking my numeric, although that this data set contains all the numeric features, but usually what happens, a data set can also contain string values, categorical variables. We want to distribute our numeric features and that. So now I'm storing my numeric features in numeric features variable. Now this is I'm printing numeric feature. These are my all, and now I want to print. Basically I want to see the distribution of all of my features. So I'm taking each of my column and using this histogram plot, and I'm going to plot this. So see, for each column in numeric features I'm going to plot. So this is the distribution of cement, and this is the distribution of next feature, which is blast furnace, and this is the distribution of next feature, which is fly ash. Same for water, super plasticizer, coarse aggregate and fine aggregate, age as well, and strength. And because we want to see if they are normally distributed or not. That is why we are interested in that. Again, now I want to see from above. We can see like some of them are not following the normal distribution, but it's okay. For now we are moving ahead. Now I want in this code, I want like check the correlations between our target variable and with my features, if they are like correlated or not. If they are highly correlated, which means they are going to uh, contribute much while predicting the strength. So that is why we are interested in that. So this is the plot, and first I'm taking in y-axis I'm taking the strength, and in x-axis I'm taking the blast furnace lag. In next plot I'm taking uh, strength versus water fly ash with all my features, and this is the numeric values. I'm checking the strength and all of my features, what is its correlation. After that I want to plot the heat map of the correlations. Like I want to check if our features correlated with each other or not. Because why we are interested in that, because say if features they are correlated with each other, they are there is no point sending them to the machine learning model while training, because the machine learning model will not learn anything new. So our agenda is to drop uh, if they are highly correlated, we want to drop one column, and I just want to give the one column to our machine learning models. So after plotting this, I can see like super plasticizer and water, they are 65, the value is 0.65 with 65%, they are correlated to each other, but it's okay, it's not a huge value, so we can continue. If like they are if they are correlated like 90, more than 90%, 95%, so in that case we need to drop one of them, or we can take like 50% of each. We can take the mean of both columns in that case. So now moving ahead, I want to check the multiple collinearity, and also I want to calculate the VIF. So for all of my features, these are my VI value. And what is the sum rule? If they're if they are closer to 10, then it's fine. And if they are, the VI value is very high, which means some of the features are correlated, so in that case we need to take care of them. So in this case, in like we can continue because VI value is not very high. From the above correlation matrix, we can see the water is highly correlated with super plasticizer, and from VIF we can also see like water has high VIF value, and uh, super plasticizer, no, water and yes, super plasticizer. So water is correlated with some of the features, so that is why. Now what is the next code? The next code is to divide the data set into dependent and independent variables. So in this I'm in y I'm storing my target variable, or you can say here it should like independent, but by mistake it is dependent here, so it's independent features, and these all are my dependent features. In x I'm storing. So after that I'm doing the trend test split, which means 80-20 split I'm doing, and the random state I'm fixing the random state, because each time I'm running my code I don't want to change the output. That is why. So again, on top of extend and extend, I'm doing a min max scaling to get the read of like uh, picture scale. So that is why. Now the machine learning models comes into the picture. First I'm initializing the linear regression in variable regressor, and dot fit function is going to train the model on train data. Again I'm after training I'm getting regression dot intercept. I want to print the intercept, and these are the coefficients, and I want to predict all my xtrain on my model regressor, and this is the predicted values. All these are the predicted values, and white train, and which means these are the uh, like the truth values, actual values again. And again I am predicting on my test data set, and this is my test predicted values, and this is the actual test values. Now again I want to check what is the mean squared error on my test data. So this is 97.60, and what is this like I'm taking the square root on top of it. So I want to pull down the values, that is why. So on white train, this is the value, and this is on test data. So this is 9 and this is 10, which is like they are closer. Now I want to check the scores, like R2 score. R2 score I want to print. Acha, one more thing is there. Uh, very like uh, very interviewer asks question, what is the difference between R2 score and adjusted R2 score. See, in R2 score we want to compare our model with baseline model, which is mean model. For every data set it is going to predict the mean, that is called mean model. So we are comparing, that is our baseline, that is our like base model. I want to compare from that, like how the model is behaving. And what is the problem in R2 square? If we are increasing the numbers of feature, our accuracy will get improved, our loss will reduce. It will give you the pseudo feel that my model is behaving good, but in actual it is not a good model, it's a dumb model. Because what may happen, the features are correlated. So in that case the adjusted R2 square comes into the picture. It takes care of that. After like adding more feature, it is not going to impact the outputs. You can also check the formula for that. So yes, that I want to say that. Now going ahead, this is the R2 score on my train data, and this is the R2 score on my test data, which we can see it is 0.59, which means it is able to capture 59% information on my train data and 62% information on my test data. Okay, so now I'm going to plot what is my predicted and actual value on my plot. This is how it looks. And now I'm again from XGBoost. I'm going to use XGBoost regressor in future, so that is why I'm importing this. Now the second model is random forest regressor. Okay, I'm using random forest regressor, and these are my parameters like maximum features, and what will be my minimum sample leaves, and what is my minimum sample split, and what are the number of trees, number of estimators. And I'm giving the hand job is equal to -1, which means if like multiple cores are present in my system, I want to use all of them to train my model. I want to parallelize my job, that is why. Now I'm using dot fit function, which means I'm going to train my random forest regression on my train data. So again after this I now see after this I'm dividing my like again I'm copying this, creating again data frame of like xtrain and xtrain. And now again I am using the random forest regressor, and in that the number of estimator are this, which means I am going to train multiple models. These are my numbers of estimators. This step is called hyperparameter tuning, and the criterion is squared error. I want to get the square error. And what is the maximum depth? I'm here, see, I'm fixing my depth. I'm just iterating over the estimators. And what is the maximum sample leaf? 52. Minimum sample split is 120. So yes, and again we know why we use this parameter and why use this. And purpose, we want to like print much more like details, that is why. Now using this function dot fit, I want to for this number of estimator I want to train my model. Now I want to see my results. So for estimated train 10, this is my train score and this is my test score, which is mean squared error. Here I have passed our criteria is squared error. Sorry, it's a squared error, not a mean squared error. Now after this I want to plot this. So now this is my in x-axis this is estimators and this is the score. Now I'm going to fix my like estimator, and now I am iterating over the depth. So again the same thing. Here you can see the estimator has been fixed. The number of estimator is 115, and for this number of depth I am going to train my model again, the random forest. So after training, this is my score. The depth is 130, the train score is 90, and the test score is 97. Again, this process is this step is called hyperparameter tuning. Now on my best result, I'll print all my values. So see, again from above results I'm passing my parameters, which is the number of estimators, the maximum depth, minimum sample split, minimum sample leave, and this is my again the random forest regression, and in this I want to print my mean test score. So and this is my mean train score, and after this I want to get my best parameter and initialize this. Again I'm after initializing I'm storing in this CLF, which is classifier, which is this is my model, final model. So on these features I want to train my final model, which is, and I want to get the square error and what is the maximum depth, this is for 14, and these all are my final parameters. I'm going to train my data sets. So after training I want to see what is my mean squared error on my train and test. So the mean squared error is 80.0 and that mean squared error on test data is 89.75. Now I want to print mean squared error, uh, root mean squared error, R2 score, and adjusted R2 score. This is for train, this is error matrix for train, and similarly for test. So here is the results, and now we can see on random forest the R2 score is 0.69, and here the R2 score on test data is 0.65, which means it is going to capture 65% of information on my test data. So now again plotting the results, and again I'm creating the copy of my data set, pen and X, and because I want to like use in my XGBoost regressor. Again defining one function which will give like it will return the mean absolute percentage error. I'll pass two parameters. So what is like the predicted and true values. Now the next code is this, our next model is XGBoost regressor, and again see we are doing hyperparameter tunings. We are using the nested condition here. So see for element in trees, this is the depth, and for the number of estimators, this is called hyperparameter tuning, where this number of combination we are going to train our model, which is XGBoost regressor. And after training, these are my results. So what is the results? So the mean absolute percentage error on test data is 374 with estimator 1000, and the depth is 4, and this is the train matrix on same, that is depth is 4 and estimator is 1000, and our mean absolute percentage error is 220. Now again I am taking my best parameters. Again I am training my model, so I want to see all the metrics because I want to compare with my previous model. So again I am printing my train error matrix and test error matrix of XGBoost model. So these are my mean square, root mean square error, r2 square adjusted r2, and this result is on test data. So we can see the r2 square on our train data is 0.96 and r2 square on test data is 0.90, which means, and also it's a good result. It's going to capture the 90% information on test data. So, and these values are very much close, which means our model is not overfit. It is well fitted model. So again, I want to see the which feature is contributing more. So one function is there, regressor dot. This is the function feature underscore importance underscore. It will give you the values for the feature importance, and these are my columns, so we can like compare, and after plotting this we can see the result. So feature 0, which means the feature cement is contributing most in the predicting the strength, and f2 is contributing less, which means 0 1, and fly ash is contributing very less. So this is the final result. So, and this is my XGBoost model is my final model. So now in this code I am going to like store my pickle file, which is class CLF, which means our model, and this is the standard scalar. So yes, after storing we can use in Flask. So yes, this was uh, from my side. Thank you for watching this video. We will discuss one more project in upcoming sessions. Thank you very much.